Hello students. Today we will learn about Introduction to Mechanism. So first of all, you have to know what is kinematics to understand what is mechanism. So what is kinematics? So it is very important to understand kinematics, kinematic link, different types of kinematic links, then kinematic pair to understand the term mechanism. So kinematics is a branch of physics which deals with the characteristics of motion without regards for the effects of forces and mass. So this is a branch of physics which deals with the characteristics of motion without regards for, that is without considering the effects of forces or mass. So this branch, that is kinematics, does not consider the effect of force or mass acting on the particular body. Now what is a kinematic link? So each resistant body in a machine which moves relative to another resistant body is called as the kinematic link or element. So each resistant body in a machine which moves relative to another resistant body is called as the kinematic link or element. It can be called as kinematic link or it can be called as an element. Now here I have told you resistant body. So what does the resistant body mean? So resistant body is one which does not undergo deformation while transmitting the force. So resistant body is one which does not undergo deformation, that is it will not change its shape or size while transmitting the motion or force, which does not undergo deformation while transmitting the force. Okay, so kinematic link can be classified into three different types. So kinematic link types. So what are they? The first one is the rigid link. The second one is the flexible link. Third one is fluid link. Okay. So there are three types. Now we will know what are this rigid link, how it is different from the other two links. So rigid link. So in this type of link, there is no deformation while transmitting the motion. So when motion is transferred from one part to other part of the machine, there will be no deformation in the links of the machine. So such type of link is called as the rigid link. So in this type of link, there is no deformation while transmitting the motion. So example for this type of link is the motion between piston and crank. So example is motion between piston and crank. Okay. Then the next type of link is the flexible link. So in this type of link, there is partial deformation while transmitting the motion. So not complete deformation, but there is partial deformation while transmitting the motion. In this type of link, there is partial deformation while transmitting the motion. So example for this type of link is belt drive. So the belt will change its shape while transmitting the motion. So belt drive is an example of the flexible link. Then the next one is the fluid link. So in fluid link, the motion is transmitted with the help of fluid pressure. So in this type of link, the motion is transmitted by fluid pressure. So example is hydraulic brake, where it is using fluids for the braking system. Okay. Then what is a kinematic pair? So we have studied about kinematic link and different type of kinematic links. Now what is a kinematic pair? So when two kinematic links are joined to have relative motion between them, then it is called as the kinematic pair. So when two kinematic links are joined to have relative motion between them, it is known as kinematic pair. Okay. Then kinematic pairs are classified as follows. So based on different factors, the kinematic pair is classified into different types. So kinematic pairs are classified as follows. So according to the nature of contact, it is classified as higher pair and lower pair. So higher pair and lower pair. So what is a higher pair? So when two links have surface contact between them, then it is known as higher pair. Surface contact means if these are, this is link 1 and this is link 2. So they are contacted at the surface of each other. So if they are in surface contact with each other, then such link, such pair is called as higher pair. So when the two links which are making the pair have surface contact with each other, it is known as higher pair. Then lower pair. When the links are in line or point contact between them, then such a pair is known as lower pair. So if this is link 1 and this is link 2, if they are at point contact with each other, then such link is known as lower pair. So when the two links have line or point contact between them, it is known as lower pair. Then according to nature of relative motion, according to nature of relative motion, they are classified as sliding pair. So here, as the name indicates, when one link slides relative to another link, then it is known as sliding pair. So here, one link slides relative to another link. Okay. Then turning pair. So in turning pair, one link turns or revolves relative to another link. So one link turns or revolves relative to another link. Okay. Then the next type is rolling pair. So here one link rolls over the other link. When one link rolls over the other link, then such pair is called as the rolling pair. Then next one is the screw pair. So here, if the pairs have turning as well as rolling motion between them, then it is known as a screw pair. So along with turning motion, even rolling motion is present between the two pairs. So if two pairs or two links have turning as well as rolling motion between them, then it is known as screw pair. The next one is spherical pair. So when a spherical link turns inside a fixed link, then it is known as a spherical pair. When a spherical link turns inside a fixed link, it is known as spherical pair. Now, according to the nature of constraint, the kinematic pair is classified as, according to the nature of constraint. Constraint is nothing but a stopping or a element which is stopping the motion. So it is classified as self-closed, pair and unclosed pair. So in self-closed pair, when two links are joined together mechanically, then it is known as self-closed pair. So when two links are joined together mechanically, then it is known as self-closed pair. What is unclosed pair? When two links are connected either due to gravity or by some external force, then it is known as unclosed pair. When two links are connected due to gravity or by some external forces, it is known as unclosed pair. Now, what is a kinematic chain? So, kinematic chain is a combination of kinematic pairs which are joined together so relative motion between elements is completely determined. So, first of all, kinematic links will make a kinematic pair. So, when kinematic pairs are joined together, to have relative motion between the elements which can be completely determined. It is we will be able to distinguish what kind of motion is present for each element or link. Then such combination of kinematic pairs is known as kinematic chain. So it is a combination of kinematic pairs joined together. So relative motion between elements is completely determined. So after knowing what is a kinematic chain, we will know what is a mechanism. So mechanism. So if you want to make a mechanism, you have to fix one link of a kinematic pair. So here you can see there are three links here, 1, 2 and 3. So if you fix one link, then this closed chain, that is the kinematic chain, is called as a mechanism. Okay, so it is formed if one link of a kinematic chain is fixed. So mechanism can be defined as combination of rigid or resistant bodies formed and connected so that they move with definite relative motion with respect to another. So first of all, I will write the definition of mechanism. So it is a combination of, that is, it consists of combination of rigid, that is, or resistant bodies. What is a resistant body? A resistant body is one which does not undergo any deformation when force is applied on it. So resistant bodies formed and connected so that they move with definite relative motion with respect to one another. So here links are connected to each other. So here you can see links 1, 2, 3, even here 1, 2, 3 and 4. All 4 are connected to each other, and also they will have some definite relative motion with respect to one another. So link 1 is fixed, link 2 is rotating or revolving with respect to this link 1. Okay, so the same way this link 3 is ideal and link 4 is also revolving here. Okay, so in this way they will have relative motion which is definite with respect to one another. So you can form many mechanisms by fixing different elements of the same chain, and this is known as inversion of kinematic chain. So what is inversion? Inversion of kinematic chain. So many mechanisms can be formed, can be obtained by fixing different elements of the same chain. Okay, so here you can see link 1 is fixed. So this has formed one kind of mechanism. So if you fix link 2, a different mechanism will be formed. And if you fix link 3, a different mechanism will be formed. So you can have many such mechanisms by fixing different elements or links of the same chain. So this is called as inversion of kinematic chain. So if in a 4-bar kinematic chain all links are free, motion will be unconstrained. So here there is a 4-bar kinematic chain here, that is it has 4 links. So 1, 2, 3 and 4. If all the links are free, then the motion will be unconstrained, that is it is not stoppable. So in a 4-bar kinematic chain, if all links are free, motion will be unconstrained. So when one link of the kinematic chain is fixed, then it works as a mechanism. So at least one link of a kinematic chain has to be fixed to make it a mechanism. So when one link of a kinematic chain is fixed, it works as a mechanism. So as I have told you, by fixing different links we can have different mechanisms. So in a 4-bar kinematic chain we can obtain 4 different mechanisms by fixing one link of the 4 links turn by turn. So when you fix link 1, there will be a different mechanism. When you fix link 2 and all the 3 links, that is 1, 4 and 3 are free, there will be a different mechanism. In the same way, by fixing different links you can have different mechanisms. So from a 4-bar kinematic chain, 4 different mechanisms can be obtained by fixing each of the 4 links turn by turn. So all these mechanisms are called inversions of parent kinematic chain. So by this, a principle of inversion of 4-bar kinematic chain, several useful mechanisms can be obtained. Now, what is a machine? So, machine is a combination of rigid or resistant bodies formed and connected so that they move with definite relative motion and transmit force. So, here it is a combination of rigid or resistant bodies formed and connected so that they move with definite relative motion and transmit force. So machine is from the source of power to the resistance to be overcome. So it is an assemblage of parts that transmit force, motion and energy in a predetermined manner. So machine is an assemblage of parts that transmit forces, motion and energy in a predetermined manner. So machine has two functions, that is transmitting definite relative motion and transmitting force. Different functions of machine, that is transmitting definite relative motion. What does a machine do? It will transmit a definite relative motion as well as transmits force. So these functions require, that is transmitting motion and transmitting force requires strength and rigidity. Okay. So this is all about the introduction to mechanism. So here we have studied about kinematics, what is kinematic link, what is a kinematic pair, different types of kinematic pairs and how they are classified. Then what is a mechanism, how mechanisms are formed, and we have studied about machine and what are the functions of machine. So I hope you have understood the topic. Thank you.